All right, cool. Thanks a lot. I'm Mike Cohen. I'm Senior Director of Product Management at Cisco, and today I'm going to be talking about policy-based infrastructure and Cisco ACI, Red Hat OpenStack, and as well I'll talk about containers and Project Contiv as well. But before I get to that, I want to give you a little bit of our vision around how we're thinking about policy and how that can actually impact the security of your environment. And all that stems from what you heard in some of the keynotes today. I believe Dave Ward spoke about it, that basically a lot of IT exists to run applications. We may love infrastructure, we may love all of the lower level pieces, but at the end of the day, we serve our customers that want to run their applications, and they want to run them in a way that's scalable, easy, reliable, and fast. And doing that requires automation. We need to be able to automate systems. We need to be able to achieve this kind of agility. But the reality is, in doing a lot of the automation, what we've ended up achieving is essentially automating human middleware. We've really taken a lot of the practices that things we used to type in our scripts into our into our CLIs, and we've ended up just making those our automation tools. And this is effectively automating human activities in the end. To some degree, we like to think of it as the industrialization of micromanagement. And really, one of the biggest risks when you do this comes from security. You start having these elaborate scripts, they may break in between, you don't know what state you end up in, and you lose control over your infrastructure, and you no longer have a defined state for it. Or define state transitions, because you've really just have a kind of a mangled set of scripts designed around automation. And really, there's another way to do this, and it's around capturing user intent and capturing the intent of your developers and making sure your infrastructure adheres to that environment. So ultimately, your application developers know their applications. They have an application, it may have a set of VMs, in a new world it may have a set of containers. They have scaling properties, they have images that they'll use, they have initialization sequences they want to run, and they have to consume certain infrastructure. They may require certain things from the storage layer, or compute, or certain placement characteristics. And they know what they depend on. If you wrote an app, you know what other things it calls, and what other pieces it actually needs to interact with. And you also know its API, so you'll know what it exposes, and then you'll be able to figure out, again, what interacts with it. Now, as you start doing this, things like security start becoming implicit. If you model dependencies and understand how the pieces of your app fit together, you now have implicit network security controlling what can talk to what. So having this level of abstraction gives you portability, self-containment, and again, tighter security, because you can actually whitelist some of these, some of the interfaces between parts of your application. And ultimately, this stems into how we think about the policy problem for our infrastructure. And we like to think about it as a set of multiple dimensions, where you actually have different teams. They need to be able to operate independently and have their own models for how things are defined. One surface of this problem is intent. What do your application developers actually want? What should talk to what? What should be enabled? Another input is the capabilities and state. What is the underlying infrastructure actually doing? What is it capable of doing? And then ops constraints. As a person running the environment, what do I need to be aware of? Do I need to enforce some degree of multi-tenancy between different workloads? Do I have certain encapsulations I need to use, or certain IOPS requirements that need to be enabled? I have these operational constraints that need to be fed into my system as well. And finally, I may have governance policies where the line of business may be telling me, you have to do things a certain way because that's how we sold it to the customer, or that's what our business requires. And in theory, all of these policies should be able to come in independently and managed by a system, and then the end result would be to configure your environment. This is ultimately the environment we want to achieve. So this led us to some observations around cloud applications and even things, as they worked in a lot of traditional, cloud environments like OpenStack and what was emerging out of Neutron. And what we thought about was if we looked at the kind of cloud application models, we saw that really they were resembling the microservices architectures that we're seeing become more popular now. There was no broadcast or multicast. They were this separate set of scalable tiers that needed to interact with each other. They didn't care about IP addresses. They were just named services talking to each other. But often what we were exposing to people were logical layer 2 networks, logical layer 3 networks, with no concept of application or dependency anymore. And really what we thought is, well, we can do better than this. And there's a couple dimensions by which we can do better. One is separation of concerns. We need to actually separate out the application requirements or the intent from the lower level requirements. What VLAN you're using from a network perspective should not be something anyone worries about. What they need to worry about is how their application is designed, how it needs to fit together. All of the operational requirements need to be completely separate from what the tenant and the developers really care about. We also need to capture dependencies. We need to understand how parts of an application interact with other parts of the application. To some degree, this is captured as you think about networks and VLANs, but in practice, a lot of that information ends up being lost. What you really want is to understand from the developer, what APIs are you calling? What APIs do you expose? So now you can understand how applications need to interact, and we can better program our infrastructure to enforce it. And then we need to enable network services. We need you to be able to insert firewalls, load balancers in a very simple way without worrying about the low-level characteristics of how they're implemented. What subnet are they attached to? Are we using a particular VLAN to connect to them? These things need to be hidden from the ultimate user so that we can dynamically stitch services together. So it's with this background that I'm going to preface my talk and introduce you to a couple different technologies that we're working on at Cisco, and also we're working with the open source community. This will include Cisco ACI and some of the technologies we're bringing out of our business unit related to that. Group-based policy, which is an attempt to create policy in the community and how we're working with Red Hat around that technology, as well as Project Contiv, which is a container-based solution that we're developing as part of an open source project to enable operational requirements in the network and in storage environments. Let me start by talking a little bit about Cisco ACI. So if you think about our strategy around switching at Cisco, we really wanted to enable customer choice. And we do this by basically giving you our switches as pure building blocks that can be deployed in a number of different ways. One of them is what we call a programmable network. Basically, you can have our switches, stick them in your traditional networks. We have great APIs, and do what you like with them. Another approach is what we call a programmable fabric, where we have a native BGP, EVPN control plane built into the switches so that you can use them to build a VXLAN fabric. At that point, you can use the fabric purely as is, configuring it via the switches independently. You can use a controller to manage it. We offer one from Cisco. We have third-party controllers that can also configure these kind of fabrics. But you can really do a mix and match approach. And the final solution is ACI, where we've really gone ahead and built a unified system that has policy-based automation across a leaf-spine fabric designed to give you the best of all worlds. And we have customers that are really using all of these technologies. So if we look across the portfolio, you'll see both merchant silicon-based switches, our Nexus 3K line, as well as our new cloud scale ASICs, which are based on the Nexus 9K. And these have a number of important new capabilities. One of the things you'll find is we're industry first to have 36-port line rate with 40, 50, and 100 gig. We can give you investment protection where we can use the same chassis across multiple technologies. We give you the same hardware regardless of the solution you're picking, our programmable networks, our programmable fabrics, ACI, all across the same actual switches. So you have complete choice of how you ultimately build your network once you buy the technology from us. We also have industry first native 25 gig all the way down to the host as well. And a single image across all of our switches. So now let me talk for a minute about ACI. So the vision of ACI was to build a network fabric consisting of our APIC controller and our Nexus 9K switches designed around policy-based automation. So we took the concepts I was talking about previously around capturing developer intent and built that as a native capability in our controller and integrated it tightly in our fabric. So we can take applications and we can easily deploy them anywhere in the fabric. And we can push policy across the network, across multiple hypervisor environment, physical server environment, tied through with network services, tied together with storage, and even tied together with connections across the WAN. We can allow you to move applications seamlessly throughout this environment. And we can do it across physical and virtual. So regardless, you may have some physical servers, you may be running multiple hypervisors together. In ACI, we can actually allow you to run all these things together. And we can give you a unified policy and unified security. And we can do that with very deep visibility. So we handle the operations problem. And this, again, becomes particularly acute in something like an OpenStack environment, where you may have users that are cloud users creating tenant networks. If they have problems, they're going to call you, and you're going to ultimately have to map those problems through to the physical layer, if that's where the problem resides. Our ACI solution can help you do that. It'll show you telemetry at the tenant level, at the application level, to help you tie these things together. So you can immediately troubleshoot the query you get from your cloud users. Of course, we have a number of customers across using this technology, and the ROIs we've seen have just been staggering, to be honest. And we have a number of case studies published around this, but this level of policy automation, our customers have seen huge advantages in operational efficiency, in the reduced time to do configuration in their network, improved security. So there's been massive ROI benefit from making the transition from a traditional networking model to the ACI environment, where we can actually manage the entire fabric and allow you to place your workloads anywhere with a single point of control. We've also made a massive investment around security, and security has been one of the biggest focuses of this technology. So one of the critical parts of ACI is whitelist-based distributed firewall. So using a whitelist here is actually really important, and it's native in our policy concept. The idea is that you should have zero trust of your applications. They should tell you, declare what they want to do, and the policy will automatically allow that traffic through. And in particular with ACI, we'll push those policies to wherever the workload ends up being deployed, and that'll be all that we actually allow to transit the fabric. So you get a tight level of security regardless of where you place the application, and you flattened out your entire network architecture. We also have a rich architecture on microsegmentation, where we can segment not just on things like a concept of a logical network, but we can also take attributes of the environment. What operating system is running in the virtual machine, or tags that may have been passed to it by the cloud platform. We can use those to actually further segment and decide what policies apply to your VM. So for example, you can find that there's a vulnerability in a particular version of your operating system. You might tag those particular VMs, and we can immediately isolate them for you until they're upgraded, and only allow them to talk to an upgrade server, for example. We can enable advanced security automation, where we can stitch together layer 4 through 7 services, firewalls, load balancers, IDS, IPS, in a very dynamic way, whether or not they're physical or virtual environments. And we also have technology coming forward around encryption and being able to do things like MACsec, so we can do end-to-end encryption across the fabric as well. One of the other powerful technologies that coming out of our group is technology called Clicker Cloud Center. So this is a recent acquisition by Cisco. And the idea around Clicker was to be a cloud automation platform, but one that's designed around policy and modeling your application templates. So again, it uses as a first-class citizen this concept of modeling dependencies between your application and allowing you to deploy that in multiple environments, be that in your private data center, on your Red Hat-based OpenStack cloud, or if you chose to use a public cloud for that application, it will actually make sure the same policy is deployed across all those environments. Another really important piece of technology that we recently announced is something called Titular Analytics. So in the security domain, I think this is something that's actually really important, and it ties together very nicely with our ACI product line. The idea behind Titular Analytics was to build a real-time appliance for gathering telemetry data from your data center and then using advanced machine learning techniques to help you understand what's going on and give you the deep visibility into how your applications are performing and how that impacts your underlying infrastructure. So critical to this is a concept of sensors. So we have both host sensors and network sensors. The host sensors will run inside the operating system. We have them supported on Red Hat today. And then we also have them available on our new switches, and they gather telemetry data that way as well. And we can give you real-time analytics as well as aggregate this data over time for doing long-term analysis and forensic information. And ultimately, a number of use cases fall out of this technology. One of the most important is application dependency mapping. We help you understand the ground truth about how your applications really are performing and how they're communicating. If you need a particular port open, you should know why. What pieces are actually talking to each other? We'll look at the packets traversing the network, and we do this in an incredibly low latency way. And we'll be able to tell you what's communicating. And you can use this to build application dependency maps that can ultimately become the basis for whitelist policies. And we actually have tools for this kind of whitelist policy generation. You can use some of our long-term forensics for things like policy compliance and auditability, proving who's talking to who, why, should they be communicating. We'll actually look at every packet and we'll be able to tell you what's actually happening. We can also look forward in time, not just backwards. We can do policy-based simulations, impact assessments. We can show you how your environment will change if you change your policy, what flows will be allowed, what flows won't be allowed, how will this impact your data center. And finally, we can enable advanced forensics. We can actually allow you to do searches against historical information about what's happening and how, and data we've gathered from this environment. So if we look a little more deeply at the architecture, you'll see that there's a data collection component, which is essentially made up of our sensors. Host sensors, which will run in a bare metal server. Oh, sorry, I think mine was behind. Or this might be, I think I'm being bitten by LibreOffice. Because it looks just fine for me here. Let me try again. No, I appreciate that. Let's see. We're here. Sorry. I was looking here. I was hoping that it matched what I was seeing here to what you were seeing there. And apparently, it doesn't. I'm going to have to proceed because apparently this tool doesn't like this slide. So, the slide deck will be available online, so I'll have to share it that way. There are some great visuals on there in the previous slide, but it looks like this particular presentation tool doesn't want to show them to you. But to go back to what I was saying about titration, so we have an idea of sensors, which are running on the host, also running inside the network. They feed information to our appliance. So we actually have an appliance that will absorb this information, do the advanced machine learning data analysis, and then make that information available over an API. So we have a GUI that's actually quite impressive, as well as a REST API where you can gather all this data. And one of the other interesting applications of the technology is tying it together with ACI. Now, titration works in any network environment. But when we use it with ACI, we can actually use it to gather policy information that we can feed in to build our application profiles for our ACI solution. And this can be a really powerful approach in how we end up doing our deployments. And you briefly saw the slide I wanted to show you, but I guess it took it away again. The other thing I'll point out around our Nexus and ACI solution is we've had amazing customer traction. We've been in the market over 2 years now, but what you would have seen is, if I go back here, is over 13,000 customers have adopted our technology. And over 7,000 are now ACI ready to actually, you're looking at doing ACI deployments. And we've also built a really rich ecosystem of partners. Over 50 partners that have done different integrations with our ACI platform. You're killing me, tool.
Maybe you want to go out to screen share mode, just move the bigger of this window into the other screen.
Let's see. I'm going to do, well that, yeah. Oh. And let's do this. Whoever told me LibreOffice would work just fine, I'm going to find you afterwards. So let me just jump ahead here, although I'm still seeing. Quite a lag. It's showing. Okay, we can do that too. Sorry, guys, we're doing my. So I'll take a step back and actually show you the titration slide now that we actually have it going. So the idea, I talked about having the set of sensors, gathering telemetry data, network sensors, host sensors, feeding them into our appliance, and the appliance exposing the GUI. As well as a REST API, as part of its solution. So, the product we end up selling is our titration appliance, and then we'll give you the sensors that you can install again on the Red Hat operating system, as well as the network sensors that work as part of the solution. And I also mentioned customer acceptance has been phenomenal, right? So we're over 13,000 customers now. On our Nexus 9K platform, over 7,000 with ACI ready, and over 50 ecosystem partners, including Red Hat, where we've been working really closely that have integrated this technology. One of the other big areas where Cisco and Red Hat have been working together is around the platform called UCSO, where we've actually gone ahead and we've taken Cisco UCS, Red Hat OpenStack, and we've built a CVD that actually shows you how to deploy these technologies together and gives you a recipe for putting together a working stack. And what we're doing now is we're extending that solution by adding ACI as part of the architecture. As I mentioned previously, the Nexus 9Ks were already part of the solution, and they support these multiple deployment models. So now we're just transitioning that to make it part of ACI, and that'll be coming later this year. So now let me go on and talk about group-based policy. So group-based policy is a project we began in the open source community that actually grew out of a lot of the observations I started the presentation with, that we should start thinking about policies and application dependencies in a different way than logical networks. We had already done this in ACI, so we built a product around this, but we hadn't done anything in the open source community. So we actually began this project, we began it in OpenStack as a way of saying, we want to expose policies as a first-class citizen in OpenStack. And the goal was to do this in a generic way. So we would build it as a plugin architecture so that you would have, we have plugins for Horizon, plugins for Heat, CLI, so that, and this plugs directly into Neutron so that you can use it with any Neutron plugin. including it'll work with ACI and our ACI plugins, but I can also use it with any network plugin. It'll map back to the existing APIs that they have. But you'll be able to capture some of the benefits of thinking about policy, thinking about dependencies, and getting, and using that as a way of deploying your infrastructure. One of the other pieces of work that's come out of that is, what's at least at the moment by the community called the NFP. So this is a part of group-based policy designed around doing, network service chaining. So in this case, we used the group-based policies to define service chains between, between different groups. And what NFP can do is it actually can stitch OpenStack VMs and dynamically steer traffic between them. And if you're interested in learning more about this, I can chat with you after, and I can also point you to the folks in the community that are driving this effort as well. So now let me talk a little bit about Cisco ACI and OpenStack. In particular, how we're working with Red Hat around this. So OpenStack has been a major thrust of our work with ACI since the very beginning. We obviously made a push around combining multiple hypervisors and physical servers, and we very quickly on in our development started working with Red Hat around how we can become the best OpenStack solution for your Red Hat OpenStack environment. And there are a number of things that came out as a result of the fabric technology we had. One of them is be able to do fully distributed neutron services. Take away the limitations around using a network node and distribute them across our fabric or around our OpFlex agents, which are the software agents we use to manage the Open vSwitch that comes in the Red Hat operating system. And through that solution, we were able to offer distributed NAT, distributed metadata proxies, distributed DHCP, and distributed routing across every compute node. But additionally, since you're using ACI, a number of other benefits come into play. You have an integrated overlay and underlay environment. So it not just benefits your cloud team who's managing OpenStack, but also your network team in that they get an automatically managed infrastructure where they can use the APIC to manage their entire fabric and bring it up at switches in a very simple manner. We give you operational visibility into the environment, and we actually suck in information from OpenStack directly into APIC so that you can do this immediate troubleshooting. So the common case I like to talk about is when a neutron network stops working, and your user calls and says, my neutron network doesn't work. Well, why could that be? It could be a lot of different reasons. It could be a problem in your Open vSwitch, could be a problem in one of your physical switches, it could be that someone yanked a cable out. Well, ACI can actually close that loop for you. Our health scores will ultimately show you that the neutron network's health is low, and we'll tie that back. If it's a physical fault inside our fabric, we'll know about that, and we'll show you exactly what happened. Someone yanked out a cable here, and that's been impacting my network. And so now you can immediately fix it and close the loop back to your, to your users of your cloud. Another place we've actually been making investment recently is also around doing multi-hypervisor in, in this environment. Now, obviously, we think everyone should be running KVM, but there's a handful of people that just can't seem to break their addiction to VMware. So we want to enable them to run that, run that architecture and still have it managed by a Red Hat OpenStack and stitched together seamlessly by an ACI fabric. That's one of the big new additions we've been making to the platform. So this picture looks a little better big, but I'll stick with it here rather than run into trouble. What? Yeah, it doesn't work at all. I'm going to stick with this for now. Okay. Thanks. So a couple of things I'll call out. If people want to see a demo, you can also reach me after, and I can show you some of these things. But basically, inside our GUI, we end up sucking information in from OpenStack using our OpFlex agents. So we have what's called a VMM domain for virtual machine management. It actually connects up to the OpenStack controller, and it receives information from that controller. So that'll include information like what hosts are under management, what hypervisors, what neutron networks have been created, and then we also get telemetry information from those. What VMs have been created, what TAP interfaces are they connected to, what IP addresses do they have, what encapsulation are they actually using to connect to our ACI fabric? Is it a VLAN or VXLAN used to connect from our physical switches down to the host, so that we can give you easy troubleshooting across those environments. And then we'll roll up and show you health scores and stats for all of these components, so if anything goes wrong, you can actually figure out exactly what happened. One of the customers that has actually been running a lot of the solution, including our Cisco ACI, Red Hat, OpenStack is SunGard, and they've spoken with us at the OpenStack Summit. They've been using group-based policy for policy-based automation of the entire infrastructure. They've been one of our big supporters, and they're deployed now live in a number of different data centers. And for reference, I like to include a number of documents that you guys can reference after the fact on the solution as well. So now let me transition for a second and talk about Project Contiv. So Project Contiv was an open source project created out of Cisco, created by some Cisco engineers with the vision of tackling the operational constraints around containers. So what we saw was a lot of the movement around containers and microservices was driven rightly so by developers, making developers' lives easier. But what was forgotten in some of this process was we still have operations teams, and they still actually have a complicated challenge in running the underlying networks and actually managing the underlying environments. And we need to make sure that we actually help them solve the operational constraints of their environment, and not, in addition to making the developers' lives easier by helping them move towards microservices and intent-based systems. See if I can make this one a little bigger so that we can see it. Okay, I'll take it. So if you look at kind of an example of what I mean here, right? If we look at something like Docker Compose was designed to capture developer intent. This is the developer says, I have these microservices. These are the guys that are talking to each other. This is what I need in terms of how they talk to each other. I'm going to give them interesting labels, so I know how they communicate. But the ops team may have a separate set of constraints. They may have to do multi-tenant isolation of these environments. They may have IOPS requirements for the storage that's connected here. They may need particular load balancers that are used for certain kind of traffic. Maybe it's a physical load balancer in some cases. It might be a software load balancer in other cases. They might want to enforce specific security between these services to make sure that they're not doing what they're not supposed to be doing. So these are the kind of things that fall into the domain of Contiv around operational policies. So if we look at the Contiv architecture and where it starts fitting into the picture, it actually comes in a number of different places. So there's a Contiv UI where you can actually monitor and manage the different policies that that are set up. There's an engine that essentially sits as part of the scheduler layer that can handle essentially receiving policies and distributing them across different hosts. And then there's a policy enforcement layer. Essentially these consist of, if you're looking at Docker, it'd be effectively end up being Docker plugins, to actually implement these different policies. And Contiv currently has plugins for both storage and networking. On the storage side, it works primarily with Ceph. On the network side, it has a number of different modes. I'll show you in a little bit. So if we look at the pieces that actually come with Contiv, one of the most important is network. Essentially helping you configure connectivity, security, multi-tenancy, in the network environment, and interact with a number of different network models. These can be pure L3 networks, L2 networks. It could be our ACI solution as well. The other big area where Contiv's made an investment is around storage, helping you handle the operational policies of storage and push them to the storage layer. Ceph has been one of the big areas of investment here, and we've been working with Red Hat around that. But you might need to configure snapshots, disk management, your quotas, limits, et cetera. Another place Contiv comes into the picture is around node management, being able to configure new nodes as they come up. And then finally, there's the Contiv Manager, which gives you the UI layer and shows you what's been configured through Contiv and how that fits into your ultimate architecture. So Contiv is an open source project, and it was designed to work with anyone's infrastructure. And it's completely, and that's the big push of the team. But they've also, there's also been some work done by teams at Cisco to enable this and help it work better with some Cisco technologies. And since Contiv is a plug-in architectures, we can actually enable these kind of things. So if you look, so one of the areas where we've made an investment is around enabling ACI. So Contiv was designed around exposing these kind of policies, so it can actually push them to our ACI layer and allow us to enforce them. In particular, things like security policies that map into our application policy model. But Contiv can also work with our Nexus switches and can enable things like L3 networks. We have L2 network topology, so it can configure a lot of standard network topologies as well. And one of the areas where we've done kind of better with Cisco is around enabling EVPN. So we have our BGP EVPN control plane, and that can actually be enabled via Contiv as well. And then the last area is around integration with UCS, where we can actually push some of the operational policies that are defined also into UCS via the UCS APIs, UCS Manager, to be able to configure them on the systems as well. So I'll leave you with a couple links to Contiv for folks that want to download it and try it out. You can try Contiv, get it from GitHub. You can run it on VMs on your laptop directly. And then we can also talk to you about how to integrate it with Cisco technologies. The team is also very available. They have a Slack channel, so if you want to get involved in any kind of Contiv development or even have trouble running it, they're very quick to help you out as well. I think on that note, that covers the material I wanted to speak about today. I'm happy to take questions. I know we have a smaller group. If anyone has any questions or wants to see kind of a deeper dive of any of this, I'm happy to talk about that as well. All right, other than that, then I'll wrap up, and I'll be here after to talk to anybody who wants. Thanks a lot.